In this video, I would like to go over graphing sine and cosine, in particular when they have a phase shift. Okay, so let's take a look at this first example. Y is equal to 3 sine, and in parentheses we have an x minus 180. Alright, if we take a look at these equations here, we see that that in our example 3 is equal to a, b is equal to 1. There's no number here, so you can just put an imaginary 1 there, so b is equal to 1. And in this case we're going to have a c equal to 180. Now I say positive 180 because the minus is already part of the formula, so c is positive, and so c is equal to 180. Alright, so let's begin the process of graphing this. Alright, so for that we need to find out the amplitude, and that's given by the calculation of the absolute value of a, or in this case the absolute value of 3 is 3, the period, which is equal to either 360 over b or 2 pi over b. Since we have 180 degrees here, I'm going to use the 360 degree formula. So 360 degrees over b, and b is 1 in our case, so we have period is equal to 360. That's the you can think of that as like the length of the wave. Okay, now we do have a phase shift, and we can find out the phase shift by setting the parentheses equal to 0. So we're gonna just rewrite the parentheses, x minus 180. We're gonna set that equal to 0 and solve. Okay, well the parentheses isn't really doing much here, so I'm just gonna go ahead and do opposites, add 180 to both sides, and I get that x is equal to positive 180. Okay, now what the phase shift is a shift in the horizontal. So let's come over a certain amount over to the right, and so I'm just going to come over here, and I'm going to say that that's 180 degrees. Okay, so instead of starting at the y-axis, now this wave is going to start over here at the positive 180 degrees to the right. Okay, all right, so it's sine wave, so it's still going to consist of one mountain and then one valley, and we're going to have an amplitude of 3, so it's going to go, the mountain's going to go way over here to positive 3, and the valley's going to go, I gotta climb, or I have to descend 3 steps down, 1, 2, 3, so that the wave is even, make it curved, and basically that's what the wave is going to look like. Now before I'm done with this, let me just label the axis. So we said that the length of the wave is the period, or 360. So then can we figure out what this number is going to be? It's not going to be 360 because I'm not starting at 0. I started at 180, so 180 plus 360 is 540. So this number here, this angle, is 540. Okay, I simply added 360 plus 180, got the 540. Okay, what about this other critical point, which is right in the middle? Well, I can add the 180 plus 540 at these two endpoints and divide by 2. And if we do that, we get that this number here is 360. Right in the middle. Okay, these are 3 intersections, three x-intercepts. They're important, but I will also ask you to find the angle where we get the high point and the low point. And for this first angle here for the high point, we are going to find the average of 180 and 360. So let's add 360 plus 180 and then divide by 2. And if you do that, you'll find out that this is 270. All right, we need one more critical point, which is over here. Let's find the average of 360 and 540. So let's add those. 360 plus 540 is 900. 900 divided by 2 is 450. And so now we are done. This is a sine wave. It consists of one mountain followed by one valley. This one has an amplitude of 3, so it goes all the way to 3, and it also drops down 3 steps. Okay, and so what's really different is that I started at 180 because of the phase shift. So every time there's a C, or that's every time C is not equal to 0, it's some number here, the graph once again is either going to move to the right or to the left depending on the signs. Okay, well, let's move on. Let's do another example. Let me erase all this. And let's do this next example. Y is equal to 2 cosine x over 2 plus pi plus 1. Okay, so let's see, before I start graphing, once again, let's find out what the letter A, or sorry, what these numbers are in the context of these formulas. All right, well, 2 is in position of the A here, so that's A. B is the number in front of x here. It's not 2x, so it's not going to be 2. B, the 2 is at the bottom, so B is equal to 1/2. C, we have a positive pi here, but we need a negative, so C is going to be equal to negative pi. And then this number here that's adding to the cosine, this is our D. So notice how D can sometimes be in front, but it doesn't have to be. It can be over here towards the back, plus D. Okay, so let's start graphing this, or let's start finding the information that we need to graph it. So the amplitude, absolute value of A, which is 2. We also need the period. Let me write a few more letters there. We are not looking for A, we're looking for the amplitude, which is the absolute value of A. Okay, so 2. All right, okay, now the period. I could do 360 over B, but I'm not, because I'm dealing with pi, so let me just keep it all in pi. So let's do 2 pi over B, or 2 pi over 1/2. We take this fraction down below and flip it, multiply, and we get 4 pi. Okay? Phase shift. Phase shift. What do? We take the parentheses and set it equal to 0 and solve, and let's see what we get. Plus pi equal to 0. Okay, so let's see. Just take away pi both sides. We get that x over 2 is equal to negative pi. And then we multiply by 2. And we get that x is equal to minus 2 pi. Okay, that's my new starting point. All right, so let's start graphing here. So instead of a cosine starting at the y-axis, we're going to have to go over to the left 2 pi. Let's just say that this is 1 pi and this is 2 pi. So I'm going to put negative 2 pi there. So negative 1 pi and negative 2 pi. Okay? Now it's cosine, so cosine is going to look like, you know, this bird. It's not the mountain valley. I'm going to come back to that in just a moment. Okay, something else that's different here is that we have a d, and d is equal to 1. So let me climb up here and put a dotted line, a horizontal dotted line through the point y is equal to 1. That's d. And this is like my new x-axis. Okay, so now I think I'm pretty much ready to graph. Let's see. So I'm not going to look down here anymore. I'm up here. This is my new x-axis. It's a cosine wave. So cosine, the wing starts at the highest point. So the high point here is, because of the amplitude of 2, I'm going to have to climb up 2. 1, 2. Okay, from the new x-axis. 1, 2. All right. So now, how long is this wave going to be? How far towards the right do I have to move? Well, the period is 4 pi. So now, if I'm calling this negative 2 pi, and this is 0, then 2 pi is over here, and the distance from negative 2 pi to 2 pi is 4 pi. So this is the ending right here. So once again, the wing is at the highest points, the two ends of the two wings. So at positive 2 and at negative 2. All right, now cosine has the lowest point at the middle. So here's the middle. How low do I have to go underneath this new x-axis? Let's take a look. The amplitude is 2, so I'm going to drop to 1, 2, right here. Okay, I think I'm ready to graph. So let's curve this. Like that. Okay, so that's the graph, and as I said, it's 4 pi in length, or the period is 4 pi. We have two critical points. We have this first angle, the start, and we have the end. The middle here is right in between, so it's 0. So we actually have 3 critical points. What is this other point here? Well, let's see. It should be negative pi, because over here we have negative 2 pi, so between 0 and negative 2 pi is negative pi, and between 0 and 2 pi is positive pi, so this point right here is pi. Okay, and that is it. Okay, let's just make sure that we understand that the amplitude is 2. So from the top of the wing to the x-axis here, the new x-axis, is a distance of 2, and that is the amplitude. But it also drops down to for the low point. Okay, so the amplitude can be down here as well. So that's also a distance of 2. Okay, and so that is it.